In this video, we're going to learn how to find the distance between 2 points. Remember, you want to make sure that your workspace is free of any distractions, get your cell phones put away, get off Instagram and Snapchat so that you can fully devote yourself to the next 10 to 15 minutes here on distance. In the first example, they're asking us to find the distance between the 2 points with coordinates -2, 1 and 4, 3. And as you might have guessed by the presence of that graph there on the paper, the very first thing that we're going to do is plot these 2 points and draw the line segment. So there's -2, 1. There's 4, 3. And that green line segment represents the distance that we're trying to find. The fact that he's slanted or tilted makes things a bit more challenging, because if this were a perfectly horizontal line segment or a perfectly vertical line segment, we would simply count the number of boxes. But what we're going to do is draw a right triangle and then use our knowledge about the Pythagorean theorem. I know that because I can count, I know that the length of that horizontal line segment is exactly 6 units. I know that the length of the vertical line segment is 2 units. And if I want to know the hypotenuse of that right triangle, I can simply use the Pythagorean theorem, or a squared plus b squared equals c squared, to find the length of the hypotenuse. Recall that when you use the Pythagorean theorem, a and b represent the legs of your right triangle, c represents the length of the hypotenuse. My legs in this case are going to be the 6 and the 2, because if I look at the picture, the 2 pieces that form the right angle in this case are the pieces that measure 6 and 2. So these guys will always be your legs. And that's going to be equal to the length of the hypotenuse squared. Now in this case, I can either say 36 plus 4, which is 40, or I could also put into my calculator 6 squared plus 2 squared and let my calculator evaluate that for me. And I'm going to go ahead and say 6 squared plus 2 squared is 40. And now in order to undo squaring the x, I want to take the square root of both sides. And I have to remember when I take the square root of 40 to consider both the positive and the negative square root. So x is going to be equal to plus or minus 40. But I know that length cannot be negative, so I'm going to automatically reject the negative solution. X is going to be equal to the square root of 40. Now, underneath the radical sign, the 40 is not a perfect square. And this is one of those things that they're not going to tell you in the question, but that you're going to need to know as you find distances. And you're going to need to know to always simplify all radicals, or always express all radicals in simplest form. So 40 is not a perfect square, but there is a perfect square that goes into 40, and that is 4. Now, I like to write my perfect square factor first, so I'm going to write this as the square root of 4 times the square root of 10, because now square root of 4 is 2. 10 isn't a perfect square, and we can't take its square root, so we end up with 2 square roots of 10. So the distance between those 2 points, 2 square roots of 10. Now this strategy, the Pythagorean theorem, works very nicely for us here on this graph. But let's suppose, or let's consider the circumstances where we're given 2 points that make the graph impractical, such as what we're given here in example 2. I don't want to draw a graph that's 103 units long or 107 units long in order to graph those 2 points. So in that case, we have something called the distance formula. And the distance formula is a formula that's going to be useful to you over and over and over in geometry class this year. You're going to want to make sure that you memorize the formula. Distance formula says that the distance between any 2 points is equal to the square root between the difference in their x-coordinates squared. So I'm going to say x subscript 2 subtract x subscript 1 squared, plus the difference in their y-coordinates squared. So y subscript 2 subtract y subscript 1 whole quantity squared. That's such an important formula that I'm going to take a minute and get out my little creative pen here, and I'm going to put stars next to that. That's something you want to know. Upside down, backwards, right side out, inside out. You want to make sure you have the distance formula memorized. So you might be saying, well, Ms. McKeon, this distance formula looks like a great little formula, but how do I use it? Do I plug in -2 for the first x, or do I substitute in 4 for the first x? And the answer to that, it really doesn't matter. The distance between -2, 1 and 4, 3 is exactly the same as the distance between 4, 3 and -2, 1. So the order in which you plug or substitute these numbers into the formula doesn't matter as long as you're consistent. For instance, when I go to substitute in the 2x values, the 2x values that I'm given here are -2 and 4. I can do -2 subtract 4 and square that quantity. Let's go ahead and do that. -2 subtract 4, quantity squared. If the -2 is the x value that I use first, then when I go to substitute in my y values, I need to substitute in the y value that belongs with that x value first. So my two y values here are 1 and 3. Because I use -2 first in the first set of parentheses, I need to use the 1 first in the second set of parentheses. And so now that I've got my equation set up, I'm going to go enter this on my calculator. And this might be counterintuitive to you at this point. You might want to say, well, I want to do mentally what's in the parentheses. Don't make it that hard on yourself. You've got a graphing calculator. Use the graphing calculator. And when I go to enter this into the graphing calculator, I always want to start with the open parentheses. So I'm going to dig out my graphing calculator. You should dig out your graphing calculator as well. Once I get to my graphing calculator, I'm going to go ahead and hit the home button. I'm going to hit choice 1 to open up a new document. I'm going to choose not to save the one that was there. And I'm going to add a calculator. And I want to enter that expression exactly as I had it on my paper. So -2 subtract 4, take the quantity and square it, plus 1 subtract 3 in parentheses, take that quantity and also square it. And I end up with, it's probably no surprise, we end up with, under the radical, the same answer that we ended up with under the radical when we performed this using the Pythagorean Theorem. And I'm going to simplify this exactly the same as we did when we used the Pythagorean Theorem. 4 is the largest perfect square that will go into 40. It goes in there 10 times, making our distance 2 square roots of 10. And again, you want to remember, always simplest radical form unless you're told otherwise. So now that we have the distance formula, we can go ahead and solve a question like number 2, where a graph really isn't a very valuable strategy. Like any other formula that you're going to use in here all year, anytime you use a formula, the very first thing that you need to do is write it on the paper. So I'm going to begin by writing down my distance formula. Distance is equal to the difference between the two x values squared plus the difference between the two y values squared. And my two x values in this case are 103 and 107. And the only thing I have to be a little careful of is when I go to substitute in the y values, I need to substitute in the y value that goes with 103. So my two y values are -8 and -2. The one that I'm going to substitute in first is the -8 because he belongs with the 103 that I substituted in first for the x values. So -8 subtract a -2, square it. And once again, when I go back here to when I go to my calculator, I'm always going to start by putting in that open parentheses. So again, I'm going to dig out my calculator. You're going to dig out your calculator so that you have some practice and some experience doing this. And I'm going to go ahead and start with the open parentheses. And in the first set of parentheses, I want to do 103, subtract 107. Then I want to square that expression. To that, I want to add in the second set of parentheses a -8, subtract a -2, and I want to square that as well. And in this instance, I get 52. Keep in mind that we did not put the square root sign into our calculator, so we still have a square root sign in our work. And we need to decide now, are there any factors of 52 that are perfect squares? And the answer to that is yes. Like the first example, 4 was a factor. 4 is also a factor here too. 4 will go into 52 13 times. So I'm going to rewrite that square root of 52 as the square root of 4 times the square root of 13, making this distance in simplest radical form 2 square roots of 13. So some things to remember for distance formula: always simplest radical form unless they ask you to do otherwise. Notice in this case they said length of the line segment. Notice that the length of the line segment is really the same thing as the distance between its two endpoints. So we use those words length and distance pretty much interchangeably. They don't mean exactly the same thing, but when you see length, you want to think to yourself, find the distance between the endpoints. Examples 3 and 4 involve a little bit more algebra, and at this point I'm feeling like I'm running out of time and I really don't want to rush to get those in, so we may take a look at those the next time that you come back to class. In the meantime though, I do want you to flip up to the top of the next page, and like always, take some time to summarize the key ideas and the important understandings that you're going to need to take away with you from this video, and then see if you can use your newfound knowledge to answer the questions there on that next page.